Welcome back to Physics, Chemistry and Quantum Physics. So today we will be discussing about mass energy equivalence, the relativistic energy, the relationship between energy and momentum and the energy of a photon. And if this is not enough, we will be also deriving all of the equations using calculus and basic algebra. Starting with E equals to mc squared. This is perhaps the most famous equation in all of physics, but very few of us know what it actually means. So let's dive deep into it. E equals to mc square basically tells us that energy and mass are both equivalent terms. Where we have energy, we have some amount of mass, and where we have some amount of mass, we have certain amount of energy. And to explain it, let me give you some examples. Imagine I have two cups of coffees which are completely identical, having the same amount of coffee in them, but one cup of coffee is hotter than the other cup of coffee. What E equals to mc squared tells us is that the hot cup of coffee will have more mass because it has more thermal energy, and that excess amount of energy results in an excess amount of mass, giving it more mass than the other cup of coffee. Now here's one more example. Imagine I have two wind-up clocks which have exact same mass, but now I wind up one clock, and now what E equals to mc squared tells us is that the winded up clock has more mass because it has more potential energy and the gears are spinning, so there is some kinetic energy, and that excess amount of kinetic and potential energy results in an excess amount of mass. That's what E equals to mc squared tells us. What I want to say is that E equals to mc squared does not mean that mass can be converted into energy or energy can be converted into mass. Basically, mass is just a quantity that represents how much amount of energy an object contains. If it has more mass, it will have more energy, and if it has less mass, it has less energy. Both are equivalent terms. Now let me introduce you to the Sun. Sun is a normal star in the Milky Way galaxy, which is composed of hydrogen and helium, and it radiates enormous amount of heat and light energy. But how does it work? Basically, the hydrogen atom inside the Sun fuse together to make the helium atom, and in that process what happens that the Sun converts its potential energy into heat and light energy, and that's the reason Sun is losing 4 billion kilograms of mass or 8.41 billion pounds of mass every second. In one of my future videos, I will be explaining you how does the Sun actually works in a very detailed manner. So stay tuned for that. The mass in E equals to mc squared is not the rest mass, it is the relativistic mass. And this relativistic mass is equal to the rest mass multiplied by the gamma function. So E equals to mc squared is same as E equals to gamma mc squared, but E equals to mc squared as the relativistic mass, whereas E equals to gamma mc squared contains the rest mass of an object. So the rest mass of an object is the mass that it has when it is stationary with respect to an observer, and the relativistic mass is the mass that an object has when it is moving with respect to an observer. And we have noticed that whenever an object moves with respect to any other object, its mass actually increases, its relativistic mass increases, its rest mass remains the same, but the relativistic mass increases due to the increase in the velocity. So this is a graph of relativistic mass of an object, and as you can see that as the object starts moving near to the speed of light, its relativistic mass increases. And as you approach the speed of light, your mass gradually increases at the rate of gamma function. And when you approach the speed of light, your mass reaches infinity. That's the reason why any body that has certain amount of mass can never ever travel at the speed of light. And few more noticeable effects that happen when you travel at the speed of light is that the time freezes, as we have learned in our video on time dilation, and our length becomes zero, as we have learned in our length contraction video. So these are some effects that happens when we reach near the speed of light or at the speed of light. So now we have discussed about this particular equation, which is known as the relativistic energy equation. Now we will be deriving this particular equation using calculus and algebra. So in order to derive this particular equation, we need to look at momentum. Momentum is mass times velocity, the rest mass of an object multiplied by its velocity. But in special relativity, we take momentum as gamma times m naught v, and this equation is known as the relativistic momentum equation. And first, we shall derive this particular equation. So we know that momentum is rest mass of an object multiplied by its velocity, and we can rewrite the velocity expression as m naught multiplied by dx over dt naught, where dt naught is the time that has elapsed for a stationary object. So we can use the so-called the chain rule to rewrite this as dx over dt multiplied by dt over dt naught. And we know that dt over dt naught, which is just the time that has elapsed for a moving object divided by the time that has elapsed for a stationary object, this term is actually gamma. So we approach that to this equation that P equals to m naught multiplied by gamma times V, and this is the relativistic momentum equation. So keeping that in mind, we will be deriving the relativistic energy equation. We know that kinetic energy is equal to the integral from x1 to x2 of f times dx. Now we can just rewrite force as dp over dt multiplied by dx, and we know the expression for momentum, the relativistic momentum equation, we know that, so we can just substitute that in. So m naught v divided by square root of 1 minus v squared over c squared. Now we can rewrite it as m naught multiplied by d over dt of v 1 minus v squared over c squared to the power of negative 1/2. Now using the product rule, we can rewrite it as m naught dv by dt 1 minus v squared over c squared to the power of negative 1/2 plus m naught v d by dt 1 minus v squared over c squared to the power of negative 1/2. Now we can focus on this particular term and simplify it. So d over dt 1 minus v squared over c squared to the power of negative 1 by 2 equals to negative 1/2 multiplied by 1 minus v squared over c squared to the power of negative 3/2 multiplied by d over dt of minus v squared divided by c squared, which can be written as now this term can be written as negative 1/2 multiplied by 1 minus v squared over c squared to the power of negative 3/2 multiplied by negative 2v divided by c squared. We can cancel out negative 2 and negative 2. So finally we have that d over dt 1 minus v squared over c squared to the power of negative 1/2 equals to dv by dt v over c squared times 1 minus v squared over c squared to the power of negative 3/2. Now we can keep this in mind and work out for dp over dt. Now we can say that dp over dt equals to m naught dv by dt times 1 minus v squared over c squared to the power of negative 1 half plus m naught dv by dt times v multiplied by v over c squared. So v times v squared divided by c squared multiplied by 1 minus v squared over c squared to the power of negative 3 half. Now we can factor out m naught dv by dt and rewrite it as m naught dv by dt times 1 divided by 1 minus v squared over c squared to the power of 1 half plus 1 divided by 1 minus v squared over c squared to the power of 3 over 2. Now this v squared over c squared will go here. So v squared over c squared. Now we just need to solve this. So m naught dv by dt and the LCM of this term is 1 minus v squared over c squared to the power of 3 over 2 and 1 minus v squared over c squared plus v squared over c squared. These terms will cancel out. So we have m naught dv by dt multiplied by 1 divided by 1 minus v squared over c squared to the power of 3 half. Now this is simply dv by dt times gamma cube. So dp by dt is equal to m naught times dv by dt gamma cube. Now we will substitute this equation in the kinetic energy equation. So we know the kinetic energy equation and we can just put the value of dp over dt. So if we do so, we get x1 to x2 of m naught divided by square root of 1 minus v squared over c squared to the cube to the power of 3 multiplied by dv by dt dx. Now what we can do is we can rewrite dv by dt times dx as dx upon dt multiplied by dv, and changing that will change the limits of the integral. So we will have the limits of the integral from 0 to v, from 0 velocity to some v velocity of m naught divided by 1 minus v squared over c squared to the power of 3 over 2 multiplied by dx over dt, it's just v, so we are left with dv times dv. So now this can be written as m naught multiplied by integral from 0 to v of v divided by 1 minus v squared over c squared to the power of 3 half dv. Now we can use the substitution method of integration to work out for this function. So let x equals to 1 minus v squared over c squared. So dx is equal to negative 2v divided by c squared dv, and we can write dv as c squared divided by negative 2v times dx. So we can put this value of dv into this equation, and doing this will change the limits of the integral to, so m naught integral from 1 to 1 minus v squared over c squared of v divided by x to the power of 3 half multiplied by c squared divided by negative 2v dx. We can cancel out v and rewrite this expression as m naught c squared divided by negative 2 multiplied by x to the power of negative 3 half plus 1 divided by 3 half plus 1 integrating from 1 to 1 minus v squared over c squared. Now we can rewrite it as m naught c squared divided by negative 2 multiplied by negative 2 by 1 times x to the power of negative 1 half integrating from 1 to 1 minus v squared over c squared. Negative 2, we can cancel out this and we are left with m naught c squared times 1 divided by square root of 1 minus v squared over c squared minus 1. And we can rewrite kinetic energy as square root of 1 minus v squared over c squared minus m naught c squared. So we notice that kinetic energy is equal to this term, and we also know that kinetic energy is equal to total energy minus the potential energy. So we can say that this is playing the role of total energy and this is the potential energy. So total energy is just m naught c squared divided by square root of 1 minus v squared over c squared. That's how you derive the relativistic energy equation. But there is a twist. Let's say if we want to calculate the momentum of a photon. So if we plug mass equals to 0 and velocity c into this particular equation, we get the result to be undefined. So that's the reason we have this particular equation. We call this equation the relationship between energy and momentum equation. And this equation is very, very useful because it can be used to calculate the energy of an object or the momentum of light. So let's say if we plug the mass equals to 0, the rest mass of the object be 0. So in that case it's only for photons. So we get the result that E equals to PC. So P can be written as E divided by C. So what this tells us is that even though light does not have mass, but it has certain amount of energy. Photons have energy because they are called packets of energy. They contain some energy. It means that even though they do not have rest mass, but they should have momentum because they have energy. And that's the reason the sunlight that is coming towards the earth pushes every 1 square inch of area at about half a billionth kilogram of weight. So this is almost negligible. But if we consider it to be on a very large scale, the results can be pretty fun. For an example, the city of New York weighs about 120 kilograms more during a sunny day because the sunlight pushes it. So now we have discussed about this particular equation, which is known as the relationship equation of momentum and energy. Let's derive it. Now let's derive this particular equation now. So first we will be looking at the relativistic energy equation, m naught c squared divided by square root of 1 minus v squared over c squared, and we know that momentum is m naught v divided by the square root of 1 minus v squared over c squared. So what we can do, we can take this equation, square both the sides, so we get p squared equals to m naught squared v squared divided by 1 minus v squared over c squared. And doing this, we get rid of the square root term. So p squared equals to m naught squared v squared. We can just solve this, so it's just c squared minus v squared, and the denominator c squared will go upside times c squared. So we get this particular term. We can rewrite it as p squared c squared minus v squared equals to m naught squared v squared c squared. So p squared c squared minus p squared v squared equals to m naught squared v squared c squared. So we can say that p squared c squared is equal to m naught squared v squared c squared plus p squared v squared. So p squared c squared can be written as v squared times m naught squared c squared plus p squared. Now v squared can be written as p squared c squared divided by m naught squared c squared plus p squared. Now we can put this value of c squared in the equation of relativistic energy. So E equals to m naught c squared divided by the square root of 1 minus 1 over c squared, and we can put the value of v squared like this. So it's just p squared c squared divided by m naught squared c squared plus p squared. We can cancel out c squared and c squared and square both the sides to get rid of the square root term. M naught squared c to the power of 4 divided by m naught squared c squared plus p squared minus p squared divided by m naught squared c squared plus p squared. We can cancel out minus p squared plus p squared, and we can rewrite e squared as m naught squared c to the power of 4, and remember that this is in brackets, c to the power of 4 divided by m naught squared c squared, and we can take this there. So m naught squared c squared plus p squared. We can cancel out m naught squared, c to the power of 2, we can make it c to the power of 2, and we have e squared equals to m naught squared c squared, so it's c to the power of 4 and plus p squared c squared, and this is the equation of the relationship between energy and momentum, and we have successfully derived it. So now we have an idea about what is the momentum of a photon. So let's look at the energy of a photon. To find the energy of a photon, we have a very amazing equation from quantum mechanics, which is E equals to h times f. So h is the Planck's constant, which is 6.626 times 10 to the power negative 34 joules times seconds, and f is the frequency of the light. So if we know the frequency of the light, we can figure out what is its energy. So let's try to solve some questions regarding it. So we have successfully discussed about E is equal to hf equation. So we will be looking at some of the questions regarding it. So question number 1, it's what is the energy of a photon with a frequency of 200 gigahertz? So we know that 1 gigahertz is equal to 10 to the power of 9 hertz. So we can say that from E is equal to h times f, we know that the energy of that photon is 6.626, the value of Planck's constant, 6.626 times 10 to the power of negative 34 joules times seconds, multiplied by f, the frequency, which is 200
gigahertz, 200. So we can write 200 gigahertz as 200 times 10 to the power of 9 hertz. Now, 1 hertz can be defined as 1 divided by seconds. So we can cancel out seconds with seconds and we can calculate this. So we can put this in a calculator and the final answer that we get is 1.32 times 10 to the power of negative 22 joules. So this is the energy of the photon with the frequency of 200 gigahertz. So let's look at the next question. The question is that find the energy of photons with wavelength of 450 nanometers. So we know that E is equal to H times F, and F can be written as H we can write F as C divided by lambda. So E equals to H times C divided by lambda, and we can just solve it now. So 6.626 times 10 to the power of negative 34 joules times seconds multiplied by 3 times 10 to the power of 8 meters per second divided by 450 multiplied by 10 to the power of 9 meters. Now, we can cancel out meters with meters, seconds with seconds. So the result that we get is 4.41 times 10 to the power of negative 19 joules per photon.
So we are done with today's video, and if you enjoyed today's video, then don't forget to leave a thumbs up and subscribe to our channel so that you would be notified whenever I release my latest video. Thanks for watching and thanks for your support.